Hello Year 8. So for the last week before we finally get back to school and resume a little bit more normality, we're going to do one more recorded lesson with me. So we're carrying on with our transformation work, and today we're going to have a look at rotational symmetry. Now our lesson objective here is to understand what rotational symmetry is, and then to recognise something called the order of rotational symmetry. That will all become clear as we work through the PowerPoint. So, rotational symmetry is how many times we can rotate a shape so that it still looks the same as we rotate it. So a shape has rotational symmetry if it looks the same after it's been rotated. The amount of times you can rotate it to look the same as the original shape is called the order of rotational symmetry. So that by the end of today's lesson, I hope that you will know what rotational symmetry is and how to count the order of rotational symmetry. So here's a rectangle. Now I've put a black spot in the top left-hand corner of the rectangle just so that we know which way up is the original shape. So here's the original shape, here's our original rectangle, the dot is at the top left-hand corner. Now if I rotate that shape around, I will find out how many times I can rotate it to look exactly the same shape. So if I rotate it round, it doesn't look like the same shape at the moment until I get to here. Now when I get to here, I'm not back to the start again because my black spot is down in the bottom right corner. I have managed to rotate it round once. So at the moment I can rotate it round once and it still looks like the same original shape. Let's see if I can go again. And there we are, I get back to the start again where it looks like the original shape. So in one complete turn, I can manage to make that shape, that rectangle, look exactly the same as the original shape twice. Once the right way round and once backwards. Let's just see that again. There's my dot in the top left-hand corner. I rotate it once and I can rotate it again until I'm back to the start. So I can show that shape in the same way twice as I rotate it round. So have a look at our next shape. So here we have a cross. There's the dot so that we know which bit of the cross is right when we get back, so we know we've done a full rotation. So we're rotating it 360 degrees, that's a full rotation. So here we go. If I rotate it round to there, I have an order of rotational symmetry of 1 because I've managed to rotate it to look the same once. My black dot isn't back at the start yet, so I can keep rotating. If I rotate it again, that's twice. I rotate it again, that's 3 times, and so that I get back to the start, that's 4 times. Oh, sorry, 4 times. Okay, I'm going to just show you that one more time. Here it goes again. So I have the same shape once, I have the same shape twice, I have the same shape 3 times, and I have the same shape 4 times. Okay, so that shape, that cross shape, has an order of rotational symmetry of 4. Right, here's another shape, an arrow. Now before I start this one, have a think about how many times you think I can rotate the shape round to make it look the same, make it cover the same shape. Okay, just have a think first. Right, let's see if you are right. So there's my dot, dot goes on the arrow. Okay, order of rotational symmetry, let's have a look. Oh, goes all the way around to that. Still not the same shape, still not the same shape, still not the same shape. Oh, hang on a minute. I can only turn it round once to make it the same shape. So my order of rotational symmetry is just 1. Let's watch it again. So it does not fit on the same shape, on the original shape, until I get back to the start. So we can't turn it and make it look the same until I get back to the start. So that's an order of rotational symmetry of 1. Right, have a look at these shapes and see if you can tell me what the order of rotational symmetry would be on these shapes. Well, I can tell you that they all have a rotational symmetry of 1, because these shapes cannot be turned around to look like the original shape until they get back to the start again. So all of these shapes have a rotational symmetry of 1, and that means they actually have no rotational symmetry. We can say that they can't be rotated to look like the same shape. Okay? Right, have a look at these ones. Now these can be rotated. They will have rotational symmetry. Let's have a think about what they will have. So pause the recording. Try and imagine that shape being turned around. How many times can you turn it around until you get back to the start before you, so that you can count the order of rotational symmetry? Right, I've written down the answers here and I want to show you how we got to those answers as well. So, here's my square. 1, 2, 3, 4. Okay, so it's every time it looks exactly the same until it gets back to the start again. So the square would have a rotational symmetry of 4. Equilateral triangle. 1, 2, 3. Now the computer won't quite let me turn it round as if my pin is right in the middle of the shape, okay, but you can imagine if you turned it round it would fit exactly on top of each other. Okay, it's just the computer won't let me do that. Parallelogram. 1, 2. I can turn that shape upside down, it will look the same, and then I can turn it back again so it's the original shape. So that one has an order of symmetry, rotational symmetry of 2. Right, hopefully you've got the idea now of how to make your shape. So this is what I would like you to do for today's activity. I will show you the worksheet in just a second. I'd like you to complete the worksheet, rotational symmetry worksheet. Now, a little bit of help. If you're finding it difficult to imagine that shape turning around, if you've got a bit of tracing paper or greaseproof paper or very thin tissue paper, you can use that to trace your shape and then put your pin or your finger or your pencil in the middle of your shape and turn your shape around. Will help you to see how many times you can turn it around until you get back to the start. If you put a little dot in the top left hand corner every time, you'll make sure that you keep going until you turn that shape around. So that will just help you if you've got a little bit of, if you need a bit of help. So let me show you what the worksheet looks like. Okay, so this is the worksheet here, rotational symmetry. It's questions 1, 2 and 3. So for question 1, it says for each of these shapes below, state the order of rotational symmetry. So if you have some tracing paper, you can put it over the top and trace the shape, put a little dot in the corner, stick your pen or pencil in the middle of the shape and turn it round. See how many times you can turn that shape round so that it looks the same, so that it overlaps the original shape. Okay, so we've got some shapes here to try. All right, and then for question 2, same thing again, but these are road signs. So with road signs, you have to be a little bit careful because although the shape can be turned around, the circle has an infinite number of rotational symmetry because we can turn it around loads and loads of times and it will look an infinite number of times and it will look the same. However, when it's got a drawing on it, when it's got a pattern on it, how many times can we make the pattern look exactly the same if we were to turn it round? Okay, and again, if you're tracing this, trace the pattern. You don't have to colour it in or anything like that, but if you trace the pattern, trace the arrows, then you can see if it will fit exactly. And for question 3, there are some flags. Again, we all know that a rectangle and a square, we should know by now what the order of symmetry is for a rectangle and a square, but when they have a pattern on them, we have to make sure that the pattern fits each other as well. So we have to, when we rotate round, make sure that our pattern looks the same at each time we rotate it. Okay, So that's today's worksheet. And then your challenge question is this. Can you draw your own shapes that have the following order of rotational symmetry? So your challenge question is to draw 5 shapes. The first one with an order of rotational symmetry of 1. In other words, it only looks the same as its original shape. Next one is 2, so in other words, it must look the same if you turn it upside down or the other way. 3, so you have to be able to turn it 3 times for it to look the same. Think about a triangle or shapes with three corners. That will help you when you're thinking about rotational symmetry of 3. And then the same for 4 and 5. Okay, now when you do your first worksheet, you might actually come up with some ideas for those. So that's today's lesson. When you have finished your work, I would like you please to upload your work to Google Classroom so that I can have a look through it. Next week, when we return to school on that Friday, we will be going on to our next topic, which is translation. But I shall also spend a little bit of time going through all of those transformations that we've looked at so far. So reflection, rotation, rotational symmetry and reflection symmetry are the ones that we've looked at so far. I'll spend a little bit of time on that at the beginning of the lesson on Friday, because I know some of you are finding it quite hard to visualise. Okay, so do your best, give me that work in, and then I will see you next Friday. Well done.